Hi, welcome back. So today in lab this week, we're going to be doing what's called a standardization. Typically when we do a standardization, it is for sodium hydroxide, at least in general chemistry. So thus far we have done acid-base reactions using titration so that we can quantify the concentration of an unknown. And for example, last week we did the concentration of acetic acid and vinegar using sodium hydroxide. So when we did those calculations, the sodium hydroxide molarity and the volume of sodium hydroxide that we titrated was then used to convert, using solution stoichiometry, to the moles of the acid and then dividing it by the acid that we titrated to get the molarity of the acid. So initially, we're using the molarity of sodium hydroxide, right? So if that sodium hydroxide concentration that we're using is not actually that concentration, then all of our other calculated numbers that we calculate are not really going to be that accurate, regardless of how accurate we are on the technique. So what we do is we react the sodium hydroxide, whatever the titrant is that you're putting in the burette, we react that in a separate reaction before we use it and figure out what its actual concentration is, okay? And that's called a standardization. And in your lab notebook, in the lab skills section for learning titrations, it goes into a pretty detailed explanation of that standardization process. So if you need a little bit more understanding and reading on that area, then please refer to that section. That would be good to read before you watch this video. Okay? All right, so I've tried to outline everything on the board for what we're going to be doing in the lab this week, and we're going to start with the chemical reaction, okay? So remember, in any titration experiment, the first thing that you want to do is write the chemical reaction equation, because we're converting one thing that we know the concentration and we're going to figure out the volume from, so we know the moles, to the moles of something else, and we need the mole ratio from the balanced chemical reaction equation. All right, so I don't have all of the species shown out here in the products for the chemical reaction, but it doesn't really matter. We only care about the mole ratio between the reactants of KHP and sodium hydroxide, and that's a 1-to-1 mole ratio. Okay, so that's all we need. So we'll start there. Okay, following along in your lab notebook, there are a couple of points that it's going to tell you to calculate, and I'm just going to highlight the most important ones here on the board. Okay, so the first thing that we're going to do when we go to do the experiment is we need to calculate how much KHP we need to weigh out, because we're going to figure out, well, how much KHP do I need to weigh out that I'm going to dissolve and put in my A, B, and C flasks. I have my sodium hydroxide made up, but I need to know how much to put in there. Okay, and so we can calculate that. That's the beauty of a standardization, is you don't need a scout, and I'll tell you about that here in a minute. You can calculate out everything that you're going to need. All right, so take a look at our pictorial diagram over here in the bottom left-hand corner of the chalkboard. Right, our basic setup is going to be where we have our sodium hydroxide going in from our burette down into our flask with KHP, and we have a certain amount of KHP in mass that we weigh out, and we put it into the flask with 25.0 mils of water that we measure out with a graduated cylinder, and then we put 3 drops of our phenolphthalein, our indicator, into that flask there. So the initial question is, how much of this KHP do we put in here? Okay, and so what we do is we say, well, we made up 0.100 molar of sodium hydroxide that I think I made up, and hopefully it's kind of accurate. Okay, but that's what I'm trying to figure out, that exact number. So I'm going to start with that number there. And I'm going to say I want to titrate approximately 20 to 24 milliliters of sodium hydroxide. We like to have about that range because that makes it pretty accurate when we quantify the actual concentration of the unknown. Is to have a range about that amount. We don't want to titrate just 5 mils. We'd like to have a nice good range, and that helps it be really accurate. So I'm just going to say I'm going to titrate about 20 mils of sodium hydroxide. So when I do that, I know how many moles of base I have added if I do that. I can then use the mole ratio to go from moles of base to moles of the KHP, okay? And then moles of KHP I can calculate very easily to go to grams of KHP, so I know how much to weigh out. So I'm going to weigh out whatever that number comes out to be, approximately around that number, 3 different times because I'm going to do 3 different runs. I know the lab manual says 4. We're just going to stick with 3 today. Okay? All right, so I'm going to do that calculation before I even start, and I want you to show that in your lab notebook. And if you're not turning in your lab notebook, I still want you to include it in your evaluation sheet that you'll be turning in for the lab, because that's really important to understand that. Okay, so I have done this calculation. You'll go ahead and do this calculation, and we're going to weigh out 3 samples of KHP that is between 20 to 24 mil volume that you titrate. So it doesn't have to be that exact number. It can be a little bit over it, but you just don't want it to be too much, because then you're going to be over 25 mils and stuff that you're going to be adding of the sodium hydroxide. Okay, so we got that. The next step is I have then weighed out the masses of KHP, and I put them, like I described over there earlier, in the bottom left-hand corner of the board. I put the mass in the flask. I went ahead and measured 25 mils of water with a graduated cylinder, so that would be 25.0 that we would record in our notebook, and then 3 drops of phenolphthalein in here, and dissolved all of the KHP. And I filled up my burette with my 0.1 molar sodium hydroxide that I'm going to eventually determine the exact concentration of. Okay? All right, so we're going to talk about number 2 point calculation, and then we're going to do the experiment, and then we're going to come back and talk about how we use that information to do the final calculation at the end. Okay, so with this particular type of titration, standardization titration, you do not need to run a scout, which is kind of cool. Okay, because we kind of already know the concentration of our sodium hydroxide, and we know the mass of the KHP that we're using. There's nothing that's really unknown right here. We're just trying to figure out the exact of something that we think it should be close to that number. Okay, so the second point here is you want to calculate the volume of sodium hydroxide base that you're going to add. We don't have to do a scout. We can calculate how much we're going to use. Okay, so we have 3 masses of KHP that I weighed out. Those 3 masses are not all exactly the same, so my volumes for my endpoint will not all be exactly the same. Okay, so I'm going to calculate the volume for each of my A, B, C flask masses of KHP I put in each one, so I know when I'm going to hit that endpoint for each one of them. Okay, so I'm going to start here. I got a mass of KHP, and I'm trying to figure out the volume of base that I'm going to be adding when I do that run. Okay, so I got grams of KHP, I can go to moles of KHP, I can use the mole ratio here to go to moles of NaOH. Okay, I'm trying to get to volume, so now I'm at moles of NaOH, and I need to get to volume of NaOH that I'm going to add for each scout. Well, I can use molarity. Molarity has moles and volume in it. I can use the molarity. It should be approximately 0.1. So I'm going to get an approximate number for that scout. Okay, so I'm going to use that approximately 0.100 molarity of NaOH and arrange those units appropriately so I end up with volume, and then convert that to milliliters of sodium hydroxide. I'm going to do that calculation 3 separate times for each of my 3 KHP masses. Okay, I can't average the masses, because then I would get an average volume, and when I go to run it, they're different masses in each flask, so you can't, it's not really the best way to do that. So you're going to get 3 different volumes for each of your individual flasks. Okay? All right, so for flask A, okay, I put in 0.409 grams of KHP. 0.409 grams of KHP. Okay, so go ahead and write that down off the balance. For flask B, okay, I put in 0.417 grams of KHP. 0.417 grams of KHP. And flask 3, I have 0.416 grams of KHP. Okay? All right, so now that our masses are weighed out in our flasks, and I got my setup ready to go, we're going to do the experiment. Okay, great. So we're ready to go. So remember that we're not doing any scouts, so before you do anything, the first thing you have to do is calculate the volume to get to the endpoint. And that would have been calculation point number 2 that was on the chalkboard that we just talked about. Okay, so we have our sodium hydroxide, approximately our 0.1 NaOH in here. I have my flask A ready to go. I make sure I have no air bubbles in the bottom of the tip of the burette, and I'm starting at 0.00 on the burette. Okay? All right, let's go. Okay, so I have already calculated the volume that I need to get to the endpoint. So I'm gonna go ahead and open it full throttle. You should have done the same. So start that. Okay, we're approaching 5 mils added. Mils we've added so far. I'm going to go ahead and stop it and just do a quick rinse on the sides. And I'm going to start it, we're a little below 16 mils right now, and I'm just going to put it on a little bit of slower, a little bit slower drip, but it's still pretty. So I had my lab assistant make up the sodium hydroxide as accurately as they could, so hopefully we're not like thrown off here by a big surprise. I do have some pink that's starting to persist a good bit, so let me put one more drop in here and take a check at it, and then we might need to start recording drop by drop. There's one drop. Okay, I think we're okay. Let's just do a couple more drops. We're not quite at 19 mils yet. We're about around 18 and a half. Okay, now we're a little past 19, so I think now is probably a good time. I'm not going to go all the way a little bit closer to where I think the end point is because I don't know how accurate my sodium hydroxide solution was prepared. So I'm going to go ahead and take it easy so I don't overshoot it and I don't have to do a 4th run. We can get by with just doing 3 runs, okay? Okay, so now we're going to start reading it drop by drop so we can try to catch the endpoint. So let's go ahead and record this volume down. Again, you want to record to 2 decimal places. And I try to do my best here so you can, and it looks like it's right at 19.1 there if you look level, the meniscus. Okay, so we're going to add a drop. Didn't go, but we'll get ready for the next drop. And if we look at it from over here, it looks like we're not quite at the 0.2. So, get your measurement. I'm going to go ahead and add another drop because I don't think that we're... Okay, now we're getting close. That pink was still persistent. Okay, that's definitely a record number now. Okay, let's get the focus there. There we go, it's focused. So 1, 2, 3. Looks like it's a little below the 3rd tick mark, so you can estimate that 2nd decimal. We're getting very close. Okay, you got it? Right at the meniscus on that tick mark. Okay, got your reading. We're so close. Maybe this next one will send it over the pink. Okay, let's get a really good reading on this one. I think we can. Okay. So we are below the 19.5 mark, so you can estimate that second digit, 19.5 guess there, your second decimal. Okay, so this, from me, in person, it looks like a very light, faint pink. I don't know if you can tell or not, but it looks very, very lightly faint pink color. So I think we're at the end point. So that previous volume that we recorded right before that drop, I think is the equivalence point that we're going to want to record to use for our calculation. Let's go ahead and we'll measure it one more time and see if we get the dark pink to show up. There it is. Called it. Okay. All right. So you want to use 2 drops previous to this flask here. Okay. Okay. So I refilled the burette and we're ready to go for flask B. The flask B mass, remember, was 0.417 grams, and I've already calculated out what the end point should be. It should be a little bit different than the first flask A that we just did. Steady speed coming out. We're approaching 7 mils added. All right, now we're heading down to about 13 mils added. 16 mils. I'm going to stop it here at like 19. Definitely persistent in there a little bit. Okay, so I'm going to go ahead and do a quick rinse with my wash bottle. And if at any time when you're adding you notice like a lot of splashing, or you accidentally bumped it or knocked the flask or something, as lots of splashing come up, you would want to stop at that point and rinse down. Okay, so we are a little below 19 mils, and I think I'm gonna let's add 1 drop here and assess before we do the drop by drop zoom in on. Okay, I'm gonna stop it here. And we're going to zoom in now. We are not quite at 20 mils, or a little out over 19.5 mils right now. And we'll go ahead and do our zoom in. Okay, so now we're gonna do drop by drop. So we're gonna record the volume, each drop we take, so we can catch that actual equivalence point. Okay, so right there, 18.567, and if I lower it right at the eye level, you can see it's a little past the 0.7. Okay, so record that in your notebook. Right on the meniscus on 0.8, 19.8. Not quite at 0.9. We're a little over the 0.9. Drops there. It's okay. We didn't overshoot it yet. Alright, right there at the meniscus, we can go ahead and record 20.00. Okay, got it. Oh, I hope I didn't overshoot it. Okay, I think we're getting really close. Okay, where are we at here? We're a little below 20.1. You estimate that second decimal place. That's right on the meniscus, I think. Got it? I think we're right at the meniscus again.
getting really close now. I think maybe the next one or the one following is going to be it. Okay, so definitely get a good measurement on this one. Okay. Oh! I thought for sure I was going to overshoot it. Okay. Go right at the meniscus on that. All right, that was awesome because that was exactly what I calculated it to be. So my lab assistant did a very good job making up this solution. They did make it up pretty accurately. Okay, so that previous volume right there that we just got is the equivalence point volume we're going to use for our calculation. Okay, on to flask C, and then we'll be done and talk about the final calculations. Okay, so our last flask here, I've went ahead and filled up the burette again, all the way back up to 0.00 on the burette of sodium hydroxide. And I've calculated out my volume I need to get to the color change. So I've added about 10 mils of sodium hydroxide right now. And now I'm approaching close to 17 mils. And I'm going to slow it again at 19. And wash down the sides. Whoops. Okay. So this flask C has 0.416 grams of KHP in it, so it should be a really, really close endpoint to the previous flask B we just ran. I'm going to put it on a slow drip. Let's go ahead and stop it here. We are right almost exactly 20 mils. So we're gonna go ahead and do the drop by drop right now because we're pretty close to the same volume as the previous flask, and the KHP mass was the very, very close. So I think we'll go ahead and here stop, be safe, just drop by drop. Okay, so we're still on flask C here, and we're doing drop by drop, so we're going to go ahead and record the volume here. It looks like it's right at the meniscus at 20, so 20.00. Add a drop. Doesn't seem like it's that close. So we're right below 20. Whoa. Okay, the volume here. Looks like it's right there on the meniscus. Okay, got it. pH right below the 0.29 oxalate. Is it reading there? It looks like it's right on the meniscus. All right, so it was that previous volume that we got. Okay, that was our equivalence point volume. So there we got all of our flasks. And now we're going to talk about our final calculation to work it up.
Okay, great. So now that we have the lab finished up, we have our 3 volumes of NaOH that we've determined, and we want to use the masses of KHP and the volumes of NaOH so that we can back calculate to figure out the actual molarity of sodium hydroxide. So if you take a look at the number 3 calculation here, calculate molarity of NaOH, that's the goal of the lab. We're going to take the mass of KHP that we have measured. We're going to do this calculation each 3 times individually. And then once we get the molarity of NaOH, then we're going to average the molarity of NaOH at the end. We can't do it like previous calculations where you can average the volume or the molarity either way. This one we do have to calculate each one separately and then average at the end. All right, so we got our grams of KHP. So for flask A, for example, this would be 0.409 grams of KHP right here, right? And we are going to convert that to moles of KHP using the molecular weight, which is provided for you at the introduction section of the lab. We're going to use the mole ratio from the equation, which is 1 to 1. Now I am in moles of KHP. I just went to moles of NaOH using the mole ratio. I'm in moles of NaOH, and I want to go to molarity of NaOH. So moles on top, I need liters on bottom. Where do I get that volume from? I'm going to use the volume that I got from the experiment that I titrated to get to the color change. All right, so you need to figure out how you're going to orient that mathematically to get moles per liter for molarity unit of sodium hydroxide. So that would be the volume that we used for flask A that you would put in here and get your molarity for flask A. We would use our mass for KHP from flask B and our volume from flask B here, get the molarity. And then the same thing for flask C, calculate it through. We got that 3 of them, and then we're gonna take the final average for that, okay? So once you do that calculation, you have your evaluation sheet. You don't need to do the second table that's authenticated by the instructor, obviously, because you didn't do it, I did. So you just show your calculation of NaOH here. I do want you to show at the bottom down here the calculations for number 1 and 2 that we talked about previously there. Okay, so you got that, and then you also have your results and discussion sheet to fill out for this lab if you need to do so. So please send me an email, you can call me if you have any questions about the lab. So I hope that you've enjoyed your titration experiments, and I'll talk to you soon. Okay, thanks, bye-bye.